Welcome, English learners, to the Global Reader. Take a moment to look around you. Whether you are listening to this story on a phone, a tablet, or a computer, you are utilizing a digital miracle, a technology so vast and so seamlessly woven into the fabric of modern life that we rarely pause to consider its history. We speak, of course, of the Internet. The story of the Internet is not just a tale of wires and signals. It is a profound narrative of human ingenuity, collaboration, and relentless innovation. It is the story of how an obscure, military-funded academic experiment grew into the largest communication network the world has ever known. This transformation has caused a societal disruption, a complete change in how we live, work, and interact, unlike anything since the printing press. Our English focus today is mastering technical and digital vocabulary that describes this revolution. These are the words you need to understand modern technology, from simple browsing to complex cybersecurity issues. We will integrate and explain over 30 such terms, guiding you through the evolution of the Internet, from its humble beginnings to its current ubiquitous status. Pay close attention to the bolded terms. They are essential lexicon for describing the architecture of the digital age. Chapter 1. The Genesis of the Network. Decentralized architecture. Our journey begins in the 1960s, a period of immense geopolitical tension. In the United States, the Department of Defense wanted a way for military and academic computers to communicate reliably, even if part of the communication system was damaged. They needed a decentralized architecture, a design where control and function are distributed among many points, not reliant on one central hub to ensure survival. The project was managed by the Advanced Research Projects Agency, or ARPA, and the resulting creation was named ARPANET. The foundational principle of ARPANET was a revolutionary concept called packet switching. Imagine sending a long letter across the country. Traditionally, you would send the whole letter in one large envelope. If that envelope gets lost, the whole message is gone. Packet switching, by contrast, involves breaking down the message, whether it's text, an image, or a simple command, into small, manageable chunks called packets. Each packet is then sent independently along the most efficient route. Once they reach their destination, they are reassembled in the correct order. The seemingly simple idea was the genesis, the beginning or origin of the modern Internet. In 1969, the very first host computer was set up at UCLA. Shortly after, 3 more were added at Stanford, UC Santa Barbara, and the University of Utah. The goal was to establish reliable connectivity, the state of being connected or linked between these academic powerhouses. The very first message ever transmitted over this fledgling network was intended to be the word login. The UCLA team managed to type L and O before the system crashed. This early failure, followed by immediate troubleshooting and correction, epitomizes the iterative process of technological development. They were building the very infrastructure, basic physical and organizational structures of the future. By the early 1970s, ARPANET successfully linked dozens of research institutions, effectively creating a small, interconnected academic community. This early form of the network laid the groundwork for everything that followed. Chapter 2. The Birth of the Protocol, TCP/IP, and the Modem. The problem with the early ARPANET was its lack of a universal language. Different types of computers, built by different companies, spoke different electronic languages. They needed a common protocol. A protocol is a set of rules governing the format of data sent and received by machines. The solution arrived in the mid-1970s with the development of the Transmission Control Protocol, Internet Protocol, or TCP/IP. This invention was the essential glue that made the Internet possible. TCP was responsible for ensuring that data packets were reassembled correctly at the receiving end, handling any lost or damaged packets with great efficiency. IP was responsible for addressing, ensuring that packet knew exactly where to go using a unique address, like a postal code. This system ensured seamless connectivity regardless of the underlying hardware. The transition to using TCP/IP as the standard protocol in 1983 is often cited as the moment the ARPANET officially became the Internet. The word Internet itself is short for internetwork. signifying its ability to connect separate, smaller networks into one massive whole. Meanwhile, the early 1980s saw the creation of key peripherals like the modem. A modem is a device that converts digital information from a computer into analog signals that can travel over telephone lines and vice versa. It was the modem that brought the world's first taste of the internet into homes, albeit at incredibly slow speeds, measured in bits per second. This was the dawn of dial-up connectivity. Academics quickly realized the utility of this system, especially for sharing research documents or archives and collaborating. They developed a fundamental service, electronic mail or email. Email quickly became the primary use case for the new network, revolutionizing academic discourse and establishing the precedent for instantaneous global communication. The Internet's infrastructure was growing, but it was still a complex, text-based system reserved mostly for scholars and scientists. Chapter 3, The Metamorphosis, the World Wide Web. The shift from the academic Internet to the global phenomenon we know today was catalyzed by one man and one invention, Tim Berners-Lee and the World Wide Web. In 1989, working at CERN, the European Organization for Nuclear Research, Berners-Lee sought a better way for scientists to share and manage research documents. The existing Internet was powerful but clumsy. It was a file repository, a centralized place for storage, without a simple way to navigate between documents. Berners-Lee's vision involved three fundamental concepts that would define the modern digital interface: HTML, hypertext markup language, the protocol for structuring content, text, images, hypertext transfer protocol, the protocol for transferring that content over the Internet, the hyperlink. This was the masterstroke. A hyperlink is a reference to data that the user can follow by clicking or tapping. Hyperlinks allowed users to jump effortlessly from one document to another, creating a web of interconnected information. In 1990, Berners-Lee created the first-ever browser, a software application that allows users to access, retrieve, and view information on the web. He also created the first web server. A server is a powerful computer or system that manages network resources. In essence, he built both the content, HTML, the mechanism for viewing it, the browser, and the distribution point, the server. The World Wide Web transformed the technical Internet into an accessible interface. An interface is a point where two systems meet, or screen layouts that allow a human to interact with a machine. Before the web, the interface was command line, requiring complex protocols. After the web, the interface was visual, intuitive, and open to everyone. The true boom began in 1993 with the launch of the Mosaic browser, which displayed graphics alongside text for the first time. The public began to see the potential of this graphical digital space. Suddenly, the Internet's connectivity became personal, not just professional. Chapter 4, The Commercial Disruption, E-commerce, and the Domain Rush. As the web exploded, the focus shifted from academic sharing to commercial opportunity. The early to mid-1990s marked the convergence process or state of coming together of technology and business. The privatization of the Internet backbone, the main data routes and connections, and the lifting of restrictions on commercial traffic opened the floodgates. Companies like Netscape, with its Navigator browser, and America Online, AOL, created easy-to-use interfaces and provide essential connectivity to millions of new users. The process of getting online often involved the distinctive, screeching sound of the modem connecting. This era saw the rise of e-commerce. E-commerce refers to commercial transactions conducted electronically on the Internet. Amazon, eBay, and many others pioneered the new field, forever changing how goods and services were exchanged. This required new standards of security, such as SSL or TLS, which uses encryption to protect user data. Encryption is the process of converting information or data into a code, especially to prevent unauthorized access. Another critical development was the domain name system, DNS. Since computers use numerical IP addresses protocols to talk to each other, humans needed a simpler system. The DNS translated easy-to-remember domain names like https://www.google.com/search q=google.com into their corresponding IP addresses. A domain name is a unique identifier for a website or service. The dot-com boom and bust showed the tremendous if often speculative, power of this new infrastructure. The underlying technology, however, continued to improve. Faster fiber optic cables dramatically increased bandwidth. Bandwidth is the maximum rate of data transfer across a given path, often measured in megabits or gigabits per second. Higher bandwidth meant lower latency, the delay before a transfer of data begins following an instruction. Reducing latency made applications feel instantaneous, paving through for video streaming and live communication. Chapter 5. The Modern Ecosystem, Cloud and Algorithms. The Internet's second great wave, often called Web 2, began around 2004. This era was defined not by technology transfer, but by user interaction. The creation of platforms like Facebook, YouTube, and Wikipedia turned passive consumers of information into active contributors. A platform is a group of technologies that are used as a base upon which other applications can be developed, or a space for sharing content. User-generated content could now spread incredibly fast, often going viral, circulating rapidly and widely from one internet user to another. Behind the scenes, the architecture shifted dramatically with the rise of cloud computing. Cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data, rather than a local server or personal computer. This provided scalability efficiency for massive services like Google and Amazon Web Services, ORS. The sheer volume of data information stored digitally generated by billions of users required a new kind of sorting mechanism, the algorithm. An algorithm is a set of rules or steps followed in calculations or problem solving. Search engines and social media feeds rely entirely on complex algorithms to filter, rank, and present information. Today, the internet is a complex, massive ecosystem, a community of interacting organisms or technologies and their environment. It is accessible everywhere, largely due to mobile connectivity. Our phones are essentially powerful clients devices that access services provided by a server in constant communication with the digital infrastructure. However, this ubiquitous connectivity brings new challenges, notably cybersecurity. Cybersecurity is the practice of protecting systems, networks, and programs from digital attacks. Issues like data breaches, phishing, and maintaining user privacy require constant vigilance and sophisticated encryption protocols. The initial decentralized design has made the internet resilient, but the human element remains the most vulnerable interface. Conclusion: the enduring digital odyssey. The story of the internet is an ongoing digital odyssey, a long, eventful, and adventurous journey. From a four-host network designed for military resilience to a global ecosystem of e-commerce, streaming, and social interaction, its growth is a monument to human ingenuity. For English learners, you have now mastered crucial technical and digital vocabulary. You can now confidently discuss architecture of a network using terms like protocol, server, and client. You understand how data is transferred via packet switching and protected by encryption. Remember, these words are the key to understanding the digital world that connects us all.